Well, hi everyone, and thanks again for joining us. It's great to be here to chat to you about developing Xamarin applications with Visual Studio. And in this webinar, we're going to do a quick overview of what Xamarin is. We'll have a look at how to get your development system up and running with Xamarin and Visual Studio. And as part of that, we'll do a bit of a tour around some of the features and look at what makes a well-architected cross-platform Xamarin application. But before we get into that, I always like to introduce myself. My name's Kym Phillpotts, and I'm an instructor at Xamarin University. And if you don't know what Xamarin University is, well, it's the place to go for the most comprehensive and up-to-date Xamarin-focused training available anywhere. And what we offer at Xamarin University is live online training by experienced instructors. You can learn everything from the basics of building a Xamarin application to advanced architecture through to data synchronization with technologies like Azure. And as a Xamarin University student, you also get access to one-on-one sessions with instructors to talk about development concepts, strategies, or even perform code reviews. And there's also an amazing Xamarin community with a private forum just for Xamarin University students and instructors, so you can get together and discuss topics. And finally, you have the opportunity to become a Xamarin certified mobile developer, which is quickly becoming a benchmark certification. Now, if you'd like to learn more or enroll in Xamarin University, please go and have a look at the website at university.xamarin.com. Our main goal for today is to build and run a Xamarin application. So let's take a step back from that and start with an overview of the process. Microsoft offers end-to-end tools for developers to create and publish mobile applications. So the Xamarin development platform lets you build native Android, iOS, Mac, and Windows applications all in C#. And this is what developers usually talk about when they discuss Xamarin. And that's actually a huge part of Xamarin, but Xamarin is a lot more than that. Building mobile applications can be really challenging. There's so many different devices and versions of operating systems that are out there. So testing is really critical. We have UI testing solutions, which you can run locally, or you can deploy them out to Test Cloud and run them on hundreds of physical devices hosted in our testing centers. Now, the Xamarin tools also enable you to build native applications written in C# for each platform. And also we integrate with numerous continuous integration pipelines. And with Hockey App, you can quickly deploy beta versions of your application to your testers to make sure your application is amazing before you go and release it out to the public. And then once your application is published, we have tools to monitor usage, track custom events, and receive crash reports. Let's talk about cross-platform mobile application architecture and have a look at how Xamarin compares to other techniques that are out there. Now, historically, if you wanted to target multiple platforms, you pretty much had to develop your application from scratch for each platform. And that meant completely rewriting your application each time you want to support a new platform. And we call this the silo approach because you often end up with multiple teams, one per platform, working in isolation. And because each dominant mobile platform uses a different programming language and different build tools, there's no code sharing or code reuse you can get there. And of course, the plus side of this approach is that you get native applications built with native tools, which offers you excellent performance and the ability to go and leverage the unique features on each of those platforms. But it can be very expensive and very slow. And of course, trying to keep parity across those platforms can be very painful as well. So another approach is to use an app generator. So this is where you write a generic application in one programming language, and it's deployed within a native shell application. So this is often done using HTML and CSS, where you essentially are shipping a web application. This approach solves some of the common problems. It uses a single code base, so the application typically only needs to be written once, but you're not deploying a native application, and it can be difficult or impossible to go and leverage the features on each of their platforms that actually make them unique. So typically these applications are fairly light on features, and they often suffer from performance problems because they're not fully leveraging that native platform. And ultimately that just leads to a poor user experience. So let's have a look at the Xamarin approach. Now with Xamarin, you write your unique UI for each platform, but you share your core business logic across those different platforms. And that's going to result in somewhere between 70 to 80% of your code being shared. And that sharing is really awesome because you get to reuse your business logic and your data access logic and your web access logic. Also, you can keep your features in parity, but you're still creating native performant applications for each of the platforms. Now keep in mind, all the code that you'd be writing here, both your UI and your business logic, is all done in C#. And that means you get all of the great .NET features you're used to, including things like the .NET types and garbage collection as well. Now, you might be worried about native platform API coverage. And of course, because we're in the C# and .NET space, we get access to all of those great .NET system namespaces. But you might ask yourself, can you use all of the platform features available, say, to Swift developers? Or can you use all of that shiny new iOS 10 feature set? And the answer is yes. Xamarin has 100% API coverage, but it's all accessible in C#. And what about Android? Well, it's the same story here, 100% API coverage, and again, all available in C#. And of course, when it comes to Windows, Microsoft already provides all of their development tools and APIs in C#. Xamarin has a long history of making very timely updates when new versions of product launches. So for iOS, Xamarin has achieved same-day release every time since iOS 5. And we do that by tracking Apple's developer previews so your SDKs are ready to go when Apple goes and launches their official updates. And that means your applications can take advantage of all that goodness right on day one. And for Xamarin Android, we track any available betas from Google and are generally able to release an SDK within a few weeks of the launch of a new Android version as well. So today, we're going to focus on mobile devices, specifically on phones and tablets. But do keep in mind that Xamarin fully supports other iOS and Android devices, so you can create applications for the Apple Watch, Apple TV, Android Wear, Amazon Fire TV. So what should you take away from all of this? Basically, anything that you can do in the native platform tools and languages, you can also do in C# when you're using Xamarin. Nothing's restricted, all the features are available. The only difference is that you can use C# along with most of the features of .NET like link and async and await, generics, delegates, and tasks. And so what about performance? Xamarin also offers exceptional performance on each platform. For iOS, your application is fully ahead of time compiled, offering you all of the performance you'd expect of a native compiled binary. On Android, Xamarin leverages just-in-time compilation, just like Java Android applications, in order to create an optimized executable that runs on the device. So Xamarin offers native performance, and with the language advantages of C# and the runtime advantages, it can actually even create applications that are faster than applications written in the native languages. Also, Xamarin is now completely open source, and because it's open source, you can download the source code, review the code to have a look at how things work, and add features and extend the platform. And if you want to contribute, and I know that you do, then Xamarin takes pull requests as well. So now that we understand what Xamarin is, let's see what you need to start developing. And the good news is Xamarin's included in the installer for every version of Visual Studio 2015, including the Community Edition. So to install Xamarin, you select the custom install option in the Visual Studio setup. Make sure that Xamarin is checked under the cross-platform mobile development section. You can do your development on a PC with Visual Studio, even when we're creating iOS applications. Now, Apple licensing requires that we do the building of the application on a Mac with the Apple SDK. And that means that we can't do everything on the Windows side, and you'll still need to have a Mac actually do the final compilation step. And the way Xamarin solves this is through a service installed on a network-connected Mac known as the Xamarin Mac Agent. So Visual Studio connects to that process and delegates a portion of that build over to the Mac, allowing us to compile with a native toolchain and launch the Apple-provided iOS simulators as well. So you'll need to run the installer on your Mac to install the build host. Our wizard is going to walk you through the setup to make sure you have access from your PC, and then you're good to go. Now, when you create or open an iOS project within Visual Studio on Windows, the IDE goes and connects across to that agent. So now that your machine is set up, let's see how to create and run an application. So Visual Studio and Xamarin tools provide everything you need to create and run an application. So with Xamarin installed, Visual Studio will have the project templates for Xamarin iOS, Xamarin Android, and Xamarin Forms. For Xamarin iOS and Xamarin Android, Visual Studio also includes design tools to help you create your UI. And for Xamarin Forms, there's also the UI previewer. Now, once your application is ready, you can run it on the Visual Studio Android emulator, the iOS simulator, or the Windows emulators. And the iOS simulator is particularly interesting because it's running on a Mac build host while you're able to interact with it remotely from your Windows machine. Okay, so let's have a look at this in action. We'll go and have a look at an existing application and we'll see how it's structured and some of the cool features of Xamarin. So the solution for this project is available from the link here on this slide. Do feel free to go and download it and have a bit of a dig through it. So let's jump over to Visual Studio. But before we get into the downloaded solution, most projects are going to start off with a file new project. So when we do that, if we come up here and say file new project, you'll notice that when Xamarin's installed, you've got a bunch of new templates that are there for different mobile applications you might want to create. For example, if we wanted to create an Android application, we have some Android templates in here for a variety of different Android projects. So we can see we can create a new blank application, an Android where we can even create a binding library so we can bind to a native third-party Android component. And there's also some testing libraries in here as well. There's also a bunch of templates for iOS as well. You can see that we have iPad, iPhone, Universal, and with each of these we have different templates for different UI structures. And we've even got things for Apple Watch and extensions here as well. And of course, as Xamarin developers, we might be interested in creating cross-platform applications. So under the cross-platform section here, you can see that there's templates for creating cross-platform native applications, as well as cross-platform Xamarin Forms applications, which we'll talk about a little bit later on. So that's the starting point for a lot of different applications. But right now, what I'm going to do is open up a solution that was created by James Montemagno that does image searching. So I'm going to cancel out of the File New dialog here, and I'll open that solution up. So this is a fairly good example of how you can structure a typical Xamarin application to go and share code across different platforms. And the first thing you'll notice about this solution is that we have 3 projects over here. We have a portable class library that has the code that we want to share. So for example, our business logic, code to access our web services and databases, basically anything that's not platform specific. And if we go and have a look inside of that project, we have our business models. And inside of there, we've got, for example, an image result, which is going to be our model for an image result that comes back. We've also got some services in here as well. So things like our Bing image search, our Google image search, and some libraries here for the cognitive services emotion APIs as well. And as you would imagine, it's a pretty good idea to put all of your code which goes and accesses services into some common code which you want to go and share. So you don't have to write it more than once and write it for each platform. And also in here, we have our view model as well, which we're going to use to centralize the code that sits behind our platform-specific UIs. We also have 2 other projects here as well. And these are the actual projects that are platform projects that we run. So we've got our Android project and we have our iOS project as well. And really the idea is to try and keep only platform-specific code within the platform projects. And normally that's going to be your UI-specific code that deals with various controls. Before we take a peek inside the platform-specific projects, let me quickly run this for you so you know that what we're going to be looking at. So I'll select the Android as my startup project here. I'll make sure that I have my emulator selected from the list of emulators. And I'm using the Visual Studio emulator for Android, which is really awesome, but you could also use the Google emulators if you wanted to, or if you had a physical device plugged in, we could select that as well. So I'll select this emulator here, go ahead and run that application. Okay, so here we are. With this application, you can just type in a search term and it will go and search for images using that term. So James would, of course, like it if we search for cute monkeys. So let's go ahead and do that. So let's come in here, type in cute monkeys, hit go. And we have our collection of cute monkey pictures in here. And I can scroll through that list as well and have a look at all those cute monkeys. But let's stop that now and go back to our Android project and have a look at that in a little bit more detail. So first of all, if we look inside of our Android project here and we go and have a look at, say, our references, you'll see that I have a reference to the image search. So that's our portable class library. That's our shared code. And so this is how our Android application gets access to that shared code. There's a bunch of other references in here as well. You'll see some of our friends like system.net and system.xml. There's some references that it might be more familiar to Android people, like our Android support libraries. And there's also some other libraries in here which have just been included to make it dead simple to go and access platform features in a cross-platform way. So things like our media plugin here, for example. Okay, but if we scoot into this project a bit further down and we have a look at our resources folder, and again, this might be something familiar to Android developers, this is basically where we put our image resources and icons and screen layouts. And speaking of layouts, one of the things that is interesting to have a look at is under this layouts folder here, which is where we have our main layout defined. So if I double click on that, you'll see that it'll load up the visual designer that we have within Visual Studio. So this allows us to lay out our screens visually. Over on the left-hand side, we can see that we have a toolbox over here, and we've got a variety of different controls which we can just drag and drop onto our design surface. Or we could go and select a control, have a look at the properties on it, and go and edit those properties. I can also go and have a look at how this layout would look in, say, landscape mode or portrait mode, and even how it would look on different size devices. So say a Nexus 10 or back to a Nexus 5. Also down the bottom here, you can see we have the source tab. So if we click on the source tab, behind the scenes, Android stores all of those layouts as XML files. And so you can edit those screens directly in XML if you'd prefer. And this is the exact same XML that is used within a native Android application. So if you're looking at an Android resource on, say, Stack Overflow, you're on the Google website, you can use that exact same layout XML that you'd find over there. So what about the code that actually makes this application work? Well, that's in the activity, and it's all written in C#. So let's go and have a look at that file. So if I go back to my Solution Explorer here and have a look at my main activity.cs. Right up the top, you can see that we have access to some Android namespaces in here. Our class is marked as an activity, so we have the label for our activity, whether it's our main launcher and its icon. And if we scroll a bit further down into our onCreate method here, you can see that we create an instance of our image search view model here. This is the same view model we declared in our shared project. So we're accessing our shared view model here. Then there's a little bit of code to set up the recycler view, and a recycler view is essentially like a grid view to go and show our results. But underneath that, you'll see that there's some code down here to go and find a button. And then beneath that, you'll see we hook up an event here. So when the user clicks on the button, first of all, we go and we disable the button. We show a progress bar. We go and call this method, this search for images async. So this is inside of our view model. So this is calling out to our shared code. And you'll notice that it's using await here. So we can use C#'s async and await so as we're not blocking our UI. And when that comes back, we then hide our progress bar and then re-enable the button. But let's go and have a look at that search for images async method and see what it's doing. So I'll go to my definition of that. And the first thing you can see, we're setting up this URL here. So this is the URL into the Bing image search. And we're going to do some web service calls here. So of course we want to add in a bit of exception handling. And because we're in .NET, we can use the standard .NET exception handling, or the try catch. And inside of here, we're creating ourselves a HTTP client. We're configuring some headers. So this is just something you need to do for the Bing image search. Then we're using that URL and we're calling off with a HTTP client to get our string back here. And this is going to return our JSON result. We then go and deserialize that JSON result using JSON.NET. And then we go and put those results into our images collection, which is going to be ultimately what populates our UI. And so if I put a breakpoint down here and perhaps down here, and I go and rerun this application, and I'll do another search, but this time we'll do it for cute koalas. And hit go. It's going to come here into my breakpoint. And if I was to have a look at my my images here, I could see my collection of images here along with their information. So I've got all of the full features of Visual Studio in here. So if I get rid of that breakpoint now and continue on, we can see we have our list of cute koalas in here. All right, so let's close that down and have a look at our iOS project. So I'll stop that, close a few windows here, and let's go and have a look at our iOS project. And if we have a look inside there, again, we see we have a references folder, and again, we can see we're referencing our image search here. So this is, again, our shared bit of logic. We also see we have things like our system namespace in here, and we've also got Xamarin.iOS in here as well, which is our bindings to our iOS APIs. Now we have a slightly different structure inside of an iOS application, but we still have a UI designer. So if we go down here and double click on our storyboard, we can load up the designer and have a look at that. And here is our designer that we have. So this is our iOS layout. And again, I can do things like I can have a look at how it would appear in different size devices, how it would appear if I rotated that. I've also got my toolbox over here where I could go and grab a control and drop it over on my design surface. And also I can select a control over here and go and have a look at its properties as well. So we have a full designer in here. Now, what about the code behind for this one? So this is a little bit different. The code behind is, for an iOS application, is in the view controller. So if we go into our view controller, up the top again, we can see that we can access all of the iOS APIs. We have access to those namespaces. If we go down into our view did load override, we can see here we've got some code that hooks up to the touch up inside event of our button. And that's essentially like the click button, the click event of the button. And we're doing exactly the same as what we did in the Android here. We're basically disabling our button, we're starting an activity, and then we're calling off to our shared code to go and do that search for images for us. And then we're of course re-enabling the button and stopping the activity indicator. So basically the complexity of our business logic and the service calls are all contained within the shared code and just called from our platform specific projects, which is pretty sweet. So let's go and run this project. And because we want to have a look and see that we have native UIs. So I'll set my iOS project as the startup project. And then I'll come up here and I'll say that I want to run this on an iPhone simulator. And when I do that, it's going to call across to my Mac Agent and it's going to work out what simulators I have connected here. And so I have this one here. And if I go ahead and run this application, it's going to load up the simulator. Now what's cool here is I'm running the iOS simulator for Windows. So it's going to launch right here inside of my Windows machine. Now technically the simulator is running over on the Mac, but it's remoting the UI back to my Windows machine. And that means that I don't have to go and switch outside of Visual Studio. And even better, if I had a touch screen here, I could go and use a touch interface. So I can come in here and I can do a search for cute monkeys. Okay, and you can see here I've got my list of cute monkeys here. And so there we go. We have our an example of running an application across multiple platforms, but sharing code. So let's go back to the slides now and talk a little bit more about code sharing. One of the big benefits of using Xamarin to develop your mobile applications is that ability to share large amounts of code across iOS, Android, and Windows. And there's several strategies you can use to share your code in a cross-platform mobile application. First, you can put your shared code into a portable class library and then reference that compiled library in each of your platform projects. So this is just like we saw with that image searching demo we looked at earlier on, where we were sharing the view model and the services. You also have the option of using a shared project and compiling the shared code directly into each platform project. And this is essentially like file linking in a set of files that get compiled with your target. It makes it dead simple to go and access platform-specific APIs from your shared code. And of course, you can incorporate third-party code from NuGet as well. And this is a great way to take advantage of literally thousands of different packages available from individuals, corporations, and the open source community. And a really good example of these are the Xamarin plugins, which provide you a way to go and access platform-specific features from your shared code. So on the slide here, we have two examples of real-world applications that take advantage of code sharing with Xamarin. And both applications share significant amounts of code. For example, iCircuit shares code across 4 different operating systems. And as we discussed, the shared code is generally the business logic, while the platform-specific code is primarily your user interface. Now, of course, the amount of shared code does vary from project to project. It largely depends on how complex your application is and the amount of effort needed to go and realize your UI using those platform-specific native controls. And of course, sharing your business logic across multiple platforms can save you a considerable amount of time and development effort. But what if you wanted to share your UI definition as well? Well, this is where Xamarin Forms comes in. Xamarin Forms allows you to create a single UI definition, but the really cool thing is that you're still going to use native UI elements for each of the platforms at runtime. When you're using Xamarin Forms, you'll still share your business logic just like you would when using Xamarin.iOS and Xamarin.Android, but now you can place your UI code in a PCL or a shared project. And that means the amount of shared code for a cross-platform application using Xamarin Forms can easily exceed 90 or 95%. But Xamarin Forms not only lets you share UI code, it also has a number of other significant development advantages as well. It has over 40 UI elements that you can use to create your UI, all of which create the appropriate native control on each platform. And we'll see how this works in just a moment. You can define your UI in XAML, and this is much like the XAML you've been using in Windows development for years. And the big advantage of using XAML and something like data binding is that it lets you achieve a really strong separation of UI from code behind, which means you have more maintainable code. And Xamarin Forms also includes a number of really useful APIs to help with navigation and animation and accessing platform features through things like the dependency service and the messaging center. So let's talk about how we create these shared UI definitions with Xamarin Forms. So first of all, we have pages, and we have a number of different page classes that encapsulate an entire screen of UI. They help you implement some core navigation patterns like master detail and stack navigation and tab navigation. And then inside your pages, we use layouts. These layouts are used to compute the size and the arrangement of the controls in your UI. It's a really nice approach, very similar to what we see in Android layouts. It makes creating well-structured, reactive UIs that work on multiple screen sizes easy to achieve. And there's a bunch of different ones to choose from, including sort of familiar styles like stack layout and grid, as well as more specialized variations like absolute layout. And these layouts can be nested as well. So for example, you could have a stack layout and one of the elements in your stack layout could be a grid layout. So it's a very powerful and a very flexible approach. And within those layouts, you're going to want to have some controls. So controls implement the core functionality of your UI. They're what the user interacts with. And all of the most common controls are available directly from Xamarin Forms. We have entry fields, labels, images, buttons, time pickers, list views, a whole bunch of different controls that you'd see across different mobile platforms. There's also an active third-party industry that provides specialized controls from some of your favorite control vendors. And if there's a control you need but you can't find it, you can go and create your own custom controls as well. As I mentioned a little bit earlier, Xamarin Forms has a powerful data binding engine built in that helps you achieve a clean separation between your UI and your code behind. And it has all the features you need like commands and type converters to let you build your applications using the very popular MVVM or model view model architecture. So you're free to build your UIs using a C# code approach, but a lot of people choose the XAML approach, which provides for better separation. And Xamarin Forms conforms to the standard XAML 2009 specification, so the syntax will be almost identical to the XAML that you've been using to build Windows UIs. And as you've seen, Xamarin Forms uses its own layouts and controls, so there's some new stuff that you'll need to learn, but your core XAML skills are going to carry over quite nicely. Here, for example, we have some XAML which has a tab page with some entry controls and a button. Now, the Xamarin Forms controls, like our entry and our button, are really abstract models. they're not actually used at runtime. Instead, for each Xamarin Forms control in your UI, a platform-specific control is created. So when we run this application on iOS, the Xamarin Forms infrastructure would go and create a UI text field. Similarly, on Android, the user would see an edit text, and on Windows, they'd be presented with a text box. This means your Xamarin Forms UI is really a native UI, and it's a native UI on every platform. You write your UI once, and it runs with the native look and feel on each platform. And the reason they feel native is because they are actually native controls. Let's go and have a look at a Xamarin Forms project and see how this all works. And the project is really just a simple weather application which allows you to type in a city, it calls out to a web service to retrieve the weather and then displays it. So as an added bonus, it's also going to use a plugin which does text-to-speech in order to say the weather. And again, feel free to download this application, have a bit of a play around with it as well. So let's go and open up that solution. And so you'll notice we have a few different projects in here. So we've got this shared portable class library here. This is our Xamarin Forms shared project essentially, where we can go and define our business logic and our shared UI. And you'll also notice that there's some platform specific projects in here as well. We have an Android, an iOS, and a UWP application. Now, even though we're using Xamarin Forms, we're still building native applications. So of course, we need to be able to build those native solutions using the native build tools so we can go and run them on our devices and our simulators and also release them out to the stores. And that's what these projects do. These are the actual projects that we run and deploy for each of our platforms. But we don't do the UI in here. Essentially, these are hosting our Xamarin Forms applications. But if you needed to include some platform-specific code, you could certainly put that code into these projects and have full access to the platform APIs. So let's dig into these in a little bit more detail. And really, our PCL here is where all of the work is done. If we open this up and we have a look underneath our references, you can see that we have references to the Xamarin Forms NuGet package in here. We've also got another couple of NuGets as well. So we've got some plugins here to do text to speech, store away some settings, and some geolocation as well. If you look further down, you can also see that we have a model in here. So we've got our shared model. So this is for our weather object, and this is the object that's going to come back to us from the weather service. So it has information like our temperatures, our minimums and maximums, a little bit about what city it's for, etc. So this is essentially our model object. And then we have our services as well. So further down here, we've got a weather service. So this is a weather service that's going to be shared by all of our applications. And what we're doing in here is we're really calling out to this open weather map API here. And so inside of here, you can see we've got this get weather method. Essentially what we do in here is we open up HTTP client, we go and format the URL based on the information that we're searching for. We go and we call off to our open weather map here to get back some JSON information, which will be our weather information. And then we deserialize that JSON information into our weather object. And then we return it back out of here. So really quite a simple service, but it is going to be shared across all of those platforms. And we also have our weather view model. So this is going to be the view model that sits behind all of our views. And so as we can go and bind our UIs to this object. So inside of here, you can see that we have our weather service here. We also have some properties which we use as well. So for example, the location, whether we're using GPS, the temperature, etc. And so this is going to be the information that is sitting behind our views. Also, if we have a look right down the bottom here, you'll see that we have commanding in here as well. So we've got this get weather command that's set up here. We have execute get weather command. And inside of here, what we're doing here is we're basically calling off to our weather service to get our weather. Then we're getting our forecast information. And then we're updating some of our properties here with the information that we get back from that. And then lastly, we come down here and we use this cool plugin here in order to be able to speak out or do text to speech for the current weather. And that brings us to our views. And the main view that we have is this one here under views. We have our weatherview.axml, .xaml. If we open that up, we can see that what we have in here is a XAML page, and we actually use binding in here as well in order to provide our data into our controls. And actually, if we quickly jump over and have a look at the app.cs file here, we can see that this is actually the starting point for our Xamarin Forms application. And we set our main page here, and in our case, we're making that point at our weather view page, and we're setting our binding context to our weather view model. So that weather view model is going to be providing the information for our weather view control. So let's close that down. Now, a really cool feature we have is the Xamarin Forms previewer as well, which allows us to get real-time previews of our XAML. And so if we can go and turn that on, we can find it under Views, Other Windows, and we have Xamarin Forms Previewer. You can see over here, we have our Xamarin Forms Previewer. And this allows us to get real-time information about what our application is going to look like, or what our XAML is going to look like for particular devices or particular form factors, different devices, and also in different orientations as well. So let's have a look at how this page is constructed. So what we have is we've got a content page in here. Inside of that content page, we've got a grid, and then we've got a background specified inside of here. So this is going to be the background, which is going to change depending on the weather information that we get back. And you'll notice that this is bound to a background image source. So this is going to come from our view model. And then inside of here, we've just got a background color. And, you know, if I was to go and change this, you'd see that we have real-time previewing here, right? So I could go in and say, change this to red, for example. Okay, so we do get real-time preview on that. Let me just undo that. Beneath that, we have another grid here, which is going to lay out our actual controls. So we can see that we have our entry field here, which is being displayed. Underneath that, we've got a button here, which is bound to our get weather command. Next, we have our stack layouts, some stack layouts down here underneath our button to show what type of weather information we want, whether we want imperial or metric. Again, you'll notice that's bound, whether we want to use GPS. And then down here, we've also got this grid here, which is being used to display these forecast bits of information. And you'll notice that the isVisible property of this is bound to our isDataAvailable. So it's only going to display if there is some data to display. And then finally down the bottom, we've got our labels here for our temperature and our condition. So these are nice big fonts, so I can basically put those values in there. Okay, but we're actually binding that to our temperature object. So that's really it. That defines our UI for our application. Now, there's also a code behind here as well, but because we're using binding and view models, there's really no code in here. If we go and have a look, it's basically got no code. But if you prefer a more traditional approach, then you could put all of your logic and event handlers and whatever you like in here. Now, before I go on and run this on a few platforms, let's have a look at the platform projects as well. So I'll just close these down. And let's have a look at what we have here. And like I said, there's not really a lot of code in here. These are really just the hosts. But inside of our Android project, if we open this up and we have a look inside of our references, we can see that we're referencing the My Weather portable class library. So this is our Xamarin Forms project. So this is how we can go and access or display that information from within our platform specific project. You'll also see that we have Xamarin Forms Core in here as well, and Xamarin Forms Platform.Android. So this is what actually goes and takes those Forms UI elements and translates them into native controls. And if we go and have a look in our main activity, you'll really see that there's not a lot going on in here as well. So in our onCreate, essentially what we're doing is we're initializing Xamarin Forms, so we're kind of bootstrapping it, and then we're loading our application. But really, that's all the code that we have in our Android project. And the same is true for our iOS application. If I close this down and we have a look at our iOS application, Inside of here, inside its references, you can see again, it's got access to My Weather. So our portable class library with our Xamarin Forms code in there, as well as it has access to the Xamarin Forms NuGet packages and Xamarin Forms platform.iOS, which is again going to take our Xamarin Forms UI elements and translate them into native controls. If we go and have a look inside of our app delegate, inside of our finish launching, again, you can see that all we're really doing here is we're bootstrapping Xamarin Forms, loading our application. This is slightly more interesting though. In this case, in iOS, we want to go and customize the font and the navigation bars. And because this is really a native iOS application, we can use some of that platform styling in here in order to set those things up, which is pretty cool. So let's go and run this on a few platforms. So first, the Android project. So I'll close this down. We'll set our Android as our startup project. Select our simulator and hit the run button. Okay, here's our application. So let's go and have a look at what the weather is like in, for example, Nadi in Fiji. And let's hit Get Weather.
24 degrees C, moderate rain.
And there we go. And you can see that it's pulling the UI from the shared code, but it's using native controls. For example, these switches and these buttons here are native Android switches and buttons. So let's have a look at what this might look like on iOS. So I'll go and stop that, and we'll set our iOS as our starting project, and we'll spin this up. So you'll notice that it's using the native iOS controls here. So let's have a look at what the weather is in, say, Jamaica.
24 degrees Celsius, clear sky.
That's pretty cool. I was actually expecting more beaches. But let's go and run this on the Windows Universal application now. Set this as our startup and go and execute that. And we already have the Ibiza in here, so let's go and have a look at what the weather's like in Ibiza.
19 degrees Celsius, light rain.
So now if we get all those applications and sit them side by side,
.24 degrees C, moderate rain. 24 degrees Celsius, clear sky.
we can see that we have the same application running, and it's all being driven from our shared business logic and our shared UI code, but they're using their native controls and they're true native applications. But the cool thing is, because we've used Xamarin Forms, we have that single code base there and it's nice and easy to maintain. Okay, so let's go back to the slides now, because there's one more topic I want to quickly cover off. And that's integrating your applications with Azure, because mobile applications often need a server-side or a cloud-based component. And that lets you serve updated content to your users, send notifications, or securely store user-generated content. And as mobile developers, our primary connection point to Azure is Azure App Services. App Services is a cloud platform specifically designed for web and mobile applications, and it encompasses a number of different services such as web apps, mobile apps, API apps, logic apps, and function apps. And when we're thinking about Azure, the server code provides support for three basic silos of functionality. First of all, the server side exposes data endpoints, which your mobile application can use to access data stored in the cloud. The mobile app service has OAuth support built in to authenticate your service endpoints using third-party providers. It also has built-in support for push notifications. And from a client's perspective, the client SDK supports the platforms that you care about, so Android, iOS, and Windows. And the advantage for the client is that it provides the SDK which layers on top of the RESTful endpoints exposed by your Azure App Services. So you work with predefined types in the Azure Client SDK, and it's going to go and create the HTTP calls and parse the results and deal with errors all on your behalf. As we've seen, one of the key benefits of using Xamarin is sharing code across all your target platforms as well. So the business logic to interact with Azure can be placed in shared code, and that means you can write the code once and enable cloud integration on all of your supported platforms. So how do we add support for the Azure Client SDK into your Xamarin application? First of all, we'll need to add the Client SDK Assemblies. These are shipped as NuGet packages. It provides several types that implement the high-level abstraction on top of your Azure REST API. Then we go and initialize the Azure SDK, so that's done in the platform-specific projects. And then we use the Mobile Services Client object, which is an Azure SDK type, to talk to our Azure services. It's responsible for managing the connection between your application and the Azure App Services. To interact with data stored in Azure, you'll need a table object, which you get from the Mobile Services Client instance. And a table object provides methods to perform standard operations like create, insert, update, and delete. So let's see how simple it is to create an Azure connected mobile application with Xamarin. So let's duck over to the Azure portal, which I have open on a browser window over here. And the first thing you're going to want to do is probably create a mobile app service backend. And you can do that by clicking the new button up here in the top left-hand corner. And inside of here, once this loads, you'll see that we have this web and mobile section. If we go and select that, inside of here, you've got all the different types of apps you can create. So you probably want a mobile application. And then what we do is we enter in our app name. So this has to be unique, and coming up with a unique name is probably the hardest bit. So let's try something like Xam Webcast. Okay, so that's all good. Then you're going to want to specify your subscription. We also have these resource groups as well. So the idea of a resource group is it groups together your app service and your databases and things like that. So it's normally a pretty good idea to create one of these. So as you can find all of your resources a little bit later on. Then we select an app service plan. In this case, I'm just using free. And then I go ahead and I hit the create button. And that'll go away and create our app service for us. And this will probably take a few minutes. And so I've already created one, and I've got a link to it here on my dashboard. It's this one called Prioritize To Do. So let's open that up. So here you can see the overview of the app service that I created a little bit earlier on. And the main thing to note here is this URL over here. So this URL is essentially the endpoint for your service. And if I go ahead and click that, you can test whether your service is actually running. So let's see how that goes. Okay, so that looks good. Our service is up and running. Now, the quickest way to get started with creating a mobile application in here is probably down in this quick start section. So if we select that, what this will allow us to do is create an application that's pre-configured to connect to your service. So let's say we wanted a Xamarin Forms application. We could come down here and select Xamarin Forms. And then there's basically 3 steps that you need to do. And I've actually already done these, but step 1 is you want to connect to a database. Step 2, you want to go and create your table API. And you can select between Node.js or a C# backend in here. Now I created a Node.js backend, and then you hit your create to-do item table. And then step 3, you have an application that you can already go and download that's connected to your service. And so you basically just go and hit this download button down here. Now I've already downloaded the application and done some slight edits on it just to make it a little bit simpler. But really what this has done is it's created as a simple to-do application. And if we go back over here and we have a look at the easy tables down here in the list down here, we can see that what it has created for us is just a simple to-do item table. And if we go inside of there and we have a look at the schema for that, it's basically got just a few fields in here. There's some for version information, but the key ones are the text for the to-do item and the completed field. Now let's go over and have a look at that downloaded application. Now, if you recall from the slides, the first thing we need to do is we need to add the appropriate NuGet packages into our project and then go and initialize the Azure mobile app services on the platform projects. And so if I just stop this, if we're going to have a look at the iOS project, under the references, you can see that the quick start's already added in those NuGets for us. So we can see that we have the Microsoft Windows Azure Mobile. And if we have a look down in our app delegate here, we can see that it's got the call in here to initialize our Azure mobile app service here. And you basically do the same thing for the other projects as well. Now let's look at the code that's been created by the quick start. And it's all in the Xamarin Forms PCL project. So let's go and have a look at that. And the first thing is we have this constants.cs. And what this has in here is our application URL that we're going to use for our Azure web service. Next, we have our to-do item, which is essentially our data transfer object, which is used to represent our table object that was created by the Quick Start project. So this is our to-do table. You see that it has things like our to-do ID, our text, and whether it's completed or not. And next, we have our to-do item manager. And this is really where all of the Azure calls happen. You'll see inside here, we have this mobile service client and we've got our to-do table. So in our constructor, we use that mobile service client with that URL for our application to go and connect to Azure. And then we go and get a table using that mobile services client. So in this case, we're getting that to-do item table. And then we have some methods to perform some CRUD operations. So for example, we've got our get to-do items async. And what this does here is it allows us to go and query that to-do table using link. And so here what we're doing is we're pulling back all of the items where the done status is false. So basically the non-completed items, and we're returning that back out of this method. We also have a save method down below. So this is our save task async. It takes in a to-do item. If it doesn't have an ID, it goes and does an insert into that to-do table, which is going to then forward it up to Azure. Or if it does have an ID, then we're going to go and update that item. So it's very straightforward code. Next, we have our UI. So let's have a look at that. So this is in our to-do list.xaml. So I'll just turn on the previewer so you can see what's happening here. Here's our screen. Essentially what we have is we've got a bit of a grid layout here. We've got an entry field for our new item, which is this one up here. We've got a button to add our items. And then below that, we've got a list view. And inside that list view, you'll see it's using binding to show the name of the item. And it also has a context action in here, which is what provides our swipe action. We've also got pull to refresh enabled as well. And then in our code behind for this, if we go and have a look at that, basically what we're doing in here is in our constructor, we're getting a reference to our to-do item manager. In our appearing, we're doing a refresh of our items. So our refresh of our items is just calling down to our manager, calling that get to do items async method, and then setting the item source. So that's basically setting the binding for this list view that we have here. Then we got a couple of methods to do things like add an item in here. So this takes a to-do item, again calls down to our manager, save task async, and then does a refresh of the items. We've got this onAdd method, which is called when the user clicks the add item button. We create ourselves a new to-do item. We get whatever they've entered into the name text field. We put it in that to-do item, and then we go and we save it away, which is basically coming up here and calling save task async. And then we go and clear out the edit box. Below that, we've got another couple of methods for completing an item. So when the user completes an item, we basically set the item done to be true, and then we go and save the task. And we've also got our on refresh. So this is called when the user does the pull to refresh. Basically what it's doing here is it's just calling down to our refresh items. And so that's it. That's all the code that you need in order to connect up to a service. So let's have a look now perhaps at customizing this solution a bit. We'll just go and add in a field for who the task is assigned to. So the first thing we might want to do is we might want to go and add that field into Azure. Now, technically, you don't need to add it in because Easy Tables will actually allow you to automatically update a schema. But let's just go and do it. Let's go back to our Azure table here, and we can see our schema for our table. And I'm just going to add a column in here. So I'll add a column in here. We'll call that assigned to. It has a data type of string. We'll click OK. Okay, and we can see that that's that assigned to has been added in there. So the next thing we want to do is we want to go and add that field into our table object in our client. So again, this is in our to-do item here. This is our table object. So I'm just going to add a property in here for assigned to. It's going to be a string, and we'll make this assigned to. All right, and we'll just add a JSON property up here just to tell it what this is mapping to essentially, and that's mapping to assigned to. All right, and so that's all the changes we need to make here on this to-do item. So go and save that. Now let's go and update our UI in order to capture that new field and update it on our list view. So we'll come back to our to-do list XAML. And what we want to do is we want to add in another text box up here. So I'll go and throw another row in here. And then we'll basically copy this entry field and we'll just rename it. So we'll call this our new assigned to. We'll put this in row 1 and we'll change its placeholder text to be assigned to, and we'll move this button down into row 2. Okay, so there we are. We've now got our new UI that we're after. But we also want to show this information on the list view. So let's come down to our list view here, and in our text cell here, let's go and add in some detail text. And we're going to get this from our binding. But also do a bit of formatting on this as well. So let's put in a string format here of assigned to, and we'll put in a detailed text color here as well. And now we just want to go and update our code behind in order to actually save away those fields. So basically in our add item here, let's go and add in that assigned to into our to-do item. Oops, I've got to change the name on my edit text, of course. So we'll change that. That is new assigned to. Oh, I better save that. There we go. And then we'll clear out this edit text down the bottom here. Okay, and I think that's it. So let's close that down, and we'll close this down, and let's go and run this on Android as a starting point. Okay, so we're good. Let's enter something in here. So let's enter in, say, I need to remember to fill in my TPS report, and we'll assign that to, I don't know, let's assign that to Jack, and we'll go and add that item in. So there we are, we've got that item in there. But let's have a look, let's see whether what happens when we run this on a second client as well, and just check that it is actually getting that information and it's sharing that information between the two. So I'll actually spin up the iOS version here. I'll just stop this, set this as my startup project, just quickly run that one. Okay, so we can see we have fill in my TPS report assigned to Jack. Perhaps we'll have another one. Let's add in, say, return my stapler to Jill. Let's add that in there. And if I come over here and I refresh this one, we can see that we've got that one. And perhaps if we go and complete this report, do a refresh over here, there we are. We can see that these are both sharing the same Azure backend. And what we have here is we've got a cross-platform application which is talking up to Azure. And, you know, it's really dead simple to set up. Let's just add another one in. We're probably ready to publish our app to the store. So before we finish up the webcast, let me just go and give you a few links to check out. So let's go back to the slides here. First of all, if you haven't downloaded Xamarin yet, you can either install it as part of Visual Studio 2015, or you can get it via the Universal Installer at Xamarin.com/download. And do make sure you check out our awesome documentation at our documentation portal over at developer.xamarin.com. There you'll find code samples, getting started guides, and our API documentation. And of course, if you want to keep learning about Xamarin and get certified, sign up for Xamarin University at university.xamarin.com. So again, a big thank you for joining us. If you have any questions after the webinar, you can always get in contact with me via my Twitter handle or shoot me an email at kym.phillpotts@microsoft.com. But right now, we have some time for questions, so please type into the Q&A window and we'll be happy to answer any questions you might have.